Ever wondered what goes into making those tiny projectiles that pack such a punch? Today, we're diving into the fascinating world of bullet manufacturing. From humble raw materials to precision-engineered components, join us as we uncover the meticulous process behind creating these essential tools of firepower. At its core, bullet making is a blend of art and science. The goal is clear: reliability and precision. Each bullet undergoes rigorous testing to meet the highest standards of performance and safety. So if you've ever been curious about what goes into making these small but powerful tools, stick around. Don't forget to like, comment, and subscribe to our channel for more insights into the fascinating world of manufacturing. Let's explore how bullets are made. The manufacturers employ a particular combination of materials to construct this rocket. Each was picked based on how it would affect the final product's functionality and safety. The bullet, or projectile itself, is frequently composed of a lead alloy. This material is a popular choice because it is affordable and gives weight. Sometimes a bullet may even have a copper jacket applied for enhanced performance. The cartridge's body is then referred to as the case. Usually, robust, long-lasting materials like brass, steel, or even aluminum are used to make these. There is a lightweight substance used for shotgun shells. It is essentially a plastic case fastened to a metal basis, according to this. These tiny parts function as spark plugs, igniting the cartridge's explosive chain reaction. The primer comes next. Usually, it's a metal cup that contains a highly sensitive substance that bursts upon contact. The propeller is, of course, the little rocket's fuel. Classic black powder and contemporary smokeless powders are examples of propellants. These meticulously blended concoctions burn really quickly, but there's so much diversity now. This produces expanding gases which force the bullet down the barrel. Speaking of which, how are bullets made? Although bullets may appear like straightforward lead slugs, they are made for a specific purpose and are available in a variety of sizes. Cold forming is a common method used by manufacturers for smaller calibers, such as the traditional .22. Lead wire is expertly cut and shaped into the appropriate bullet form using a massive automated press. The rapid speed of this approach makes mass production possible. Casting is a more conventional approach that is crucial for competition shooters. Before it is cooled and removed, molten lead is poured into molds to form the bullet shape. An increase to copper might be advantageous for both cast and cold form bullets. The bullet's exterior is coated with a thin layer of copper using a procedure known as plating. The copper jacket does two things. It first prevents rust of the lead core. Secondly, it produces a more resilient surface to hold onto the spiral grooves within the barrel. We refer to those as rifling. The bullet is sped up by this rifling, which is crucial for hitting your target precisely where you want. After a long day of shooting, the copper jacket does another useful job of keeping your pistol clean. Now, let's discuss the cartridge casing. The bullet is held in place by this modest small brass cup. Again, brass reigns supreme, though it can also be made of steel, aluminum, or even plastic. It's just really durable and easier to produce. The case's design now relies on the type of gun it will be used with. Punches and dies are the tools used to crush and shape brass sheets. Up until the rim is precisely the right shape, each stage deepens and refines the metal. After they're trimmed and have a hole punch for the primer, the cases get a heat treatment. This makes the metal stronger. It's now ready to handle the pressure of firing. Some cases might get dipped in nickel too. They become even more resilient and rust-resistant, and have a somewhat more stylish appearance as a result. Lastly, each case is given a small tattoo containing information about the case's caliber, maker, and other pertinent details so that we can locate it if necessary. The primer is tucked inside the cartridge. It essentially acts as the operation's spark plug, starting the series of events that propels the bullet. The primer is rather basic, yet it accomplishes a great deal with two crucial components that function in unison. The cup is the initial component. It's roughly the size of your pinky nail on a tiny pistol, and it's typically composed of soft copper or brass. Inside the small cup sits an even smaller amount of a super-sensitive material called lead stiphanate. The anvil is the second component. Within the cup lies a little triangular metal component. The lead stiphanate is hammered against a surface provided by the anvil. Your gun's firing pin smashes the primer when you pull the trigger. The center of the cup is crushed by this blow, which forces the lead stymie firmly against the anvil. A brief burst of flame is released via a specific hole in the case when the pressure causes the lead to stiffenate and explode. The propellant or gunpowder is then set on fire by this flame. We've seen the processes used to create the propellants, primers, casings, and bullets. What about the way these parts are assembled to create a full cartridge? We start the adventure with a thorough cleaning. This optimizes them for peak performance. Once the cases are ready, the true assembly magic takes place. To ensure that every case is precisely the correct size for firing, it goes through a unique process. Next, a primer is cautiously placed in the case's assigned location. To prevent any issues loading into the rifle's magazine, it must fit precisely. The case mouth stretches slightly to accommodate the bullet as the primer settles in. Adding the gunpowder is a very important step that follows next. However, we must measure this material precisely because any errors could be extremely harmful. It's time to take a seat. Each component must be fed exactly and in the correct order. The long-lasting and minute adjustments are made using specialized instruments known as dies. Errors such as misplacing the primer or inserting the bullet incorrectly may result in issues or maybe result in a hazardous explosion. The completed cartridges are finally packaged nicely after all this meticulous effort, usually in packs of 50. They're prepared to visit a responsible gun owner's collection or the shooting range. Making ammunition involves more than just assembling components. It involves creating something that functions flawlessly each and every time. That's where some factory testing and quality control are useful. Each batch is tested via thousands of rounds that are tested by the manufacturer. They gauge the bullet's flight accuracy, pressure buildup during firing, speed down the barrel, and, most importantly, the consistency of each of these parameters throughout the batch. They employ specialized high-tech firearms with sophisticated electronics to obtain these incredibly accurate measurements. Additionally, every ammunition batch has a unique code printed on the box. They can monitor everything with the aid of this code, and in a very unlikely situation. Something is wrong with a batch. They can quickly recall and swap out those particular rounds. Although bullets have been used for centuries, this does not mean that they are relics from the past. Ammos is always changing to accommodate various users' needs.